Okay? Okay, here.
Okay.
All right, so dextrose, where you see dextrose? Dextrose you saw in the hospitals, right? Or patients who have an IV line and they put dextrose, that is glucose. Okay, all right, so that is the monosaccharides. Uh, I want to focus in the polysaccharides. Polysaccharides. Polysaccharides means multiple molecules of carbohydrates together. The one that you need to remember very well is the starch. It's a polysaccharide, starch. We have the fiber. Fiber is cellulose. So fiber is the same to say cellulose. So where is the cellulose? The cellulose are in the salads, in the fruits. So it's the fiber. It's called we can call that dietary fiber because it's a fiber coming in the diet. And this is cellulose, of course. So what is the situation of cellulose? Cellulose fiber or dietary fiber is the same, are not digestible. So you cannot digest the cellulose, the fiber. What does it mean, digestion? Digestion, in simple words, just don't complicate your life. Just simple. Digestion means breakdown, breakdown. Digestion is breakdown. So the question is, why you want to break down? You want to break it down because you want small particles, small molecules, in order to be able to pass the cell membrane. Otherwise, will not be absorbed. Absorb is when some substance passes from one place to another place. That is absorption. So that means they need to cross through the cell membrane. And in order to pass the cell membrane, they need to be tiny, 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 very tiny. And that's why we call that, in order to obtain that size, that is through a process called digestion. Okay, so the cellulose cannot be digested in this case. Cellulose cannot be digested. So if the cellulose cannot be digested, cannot be absorbed. Okay? So you in your mind you're thinking, so what we need to eat cellulose? So why we need to eat fiber if we don't digest and we cannot absorb? It's not going to be part of our nutrients in our blood, no? And the answer is very simple. The fiber or cellulose is going to be the plants and salads that contain fiber have high content of vitamins and minerals. That's why we need to eat salad and fruit. In addition, something else I'm going to tell you very right now. But it's like you have a sponge with fluid, you squeeze the sponge, and the fluid coming out. The sponge is not going to change. It's going to be the same. Who is the sponge? The cellulose, fiber or dietary fiber. Who it is representing the water is an analogy, okay? It's going to be the vitamins and minerals, okay? So cellulose, that is one of the main functions of the cellulose, to carry the vitamins and minerals. Second, the cellulose is going to suffer a mutual collaboration with bacteria. This bacteria is found in the colon, in the colon. This bacteria is called the good bacteria. This bacteria is called the flora, normal flora or flora. And these guys are good bacteria. They're good bacteria. And why we call good bacteria? We call good bacteria because these bacteria inside the colon, are going to eat what we cannot digest. In this case, the cellulose. Again, the cellulose, yes. The cellulose is going to be eaten by these bacteria. They are going to digest the fiber. So what we earn from that? So why we want to feed the bacteria inside your body? Very simple, because the bacteria, when they digest the cellulose, is going to produce vitamin K, vitamin K, vitamin K, vitamin K. This vitamin K is produced inside the large intestine, and then they go to the bloodstream. So what is the vitamin K? What for? Vitamin K is for the coagulation process. Coagulation process. What means coagulation? To create clots, clots, clots. So when you have an injury, you injure your finger, you're not bleeding until you die. You're going to bleed at a certain point where the coagulation process stops the bleeding. So we need coagulation process to form clots 24/7. Look at me. If I do this in my arm, like this only, I break some capillaries already. I break it, but I don't have bruises. Why? Because my coagulation process are going to work 24/7. We okay with that?
Yes.
Yeah.
Excellent. Now let's go to lipids and cholesterol. Talking about lipids and cholesterol, cholesterol is going to be a precursor or originate the hormones, steroid hormones. So tell me, somebody can tell me what is synthesis, please. I'm going to write it down in the chat box. What is that? Somebody? It's okay to say no, I don't know. It's not it's not right to say I don't care. I don't mind. You tell me I don't know, I will tell you.
I don't
Synthesis.
know.
Okay,
I don't
excellent.
know.
Excellent. All right. So synthesis is a word that you're going to see in many exams. In NCLEX, ATI, practice, everywhere. So synthesis is a word that is very common to find in any exam. So synthesis is better you to remember what is the meaning of synthesis. Very simple. Synthesis means production. So when you see the word synthesis in whatever reading, you're going to translate in your mind that is production. It's going to produce. For example, the ovaries produce estrogen, or you can say ovaries synthesize estrogen. The thyroid gland produce or synthesize thyroid hormones. You can say the thyroid gland synthesize thyroid hormones. Okay, so it's the understanding is important, but the way they ask questions is again important to be alert on that. Okay, all right, you okay with that?
Yes.
Yes.
Okay, okay. Tell me, do you see what I do? Can you see my screen?
No.
No.
Good. Okay, thank you. All right. So cholesterol. What is cholesterol? Please, the lipids. Please, I want to mention this. Don't be afraid of this. So lipids is the same to say fat. Yes, fat lipids. What is this? Fat. What is this? What is lipid? Fat. What is fat? Lipid. Fat, lipid. Lipid, fat. No problem. The lipids or fats are classified in three. Number one, fatty acids. Fatty acids. Fatty acids. Number two, triglycerides. Number two, triglycerides. And number three, cholesterol. Number three, cholesterol. So fatty acids, triglycerides, and cholesterol. The fatty acids are very important, and you will see the classification of fatty acids are going to be in saturated and unsaturated fatty acids. Saturated and unsaturated fatty acids. The saturated is the animal fat. Saturate, animal fat. And the unsaturated is the oils, vegetable oils, oils. For example, one fatty acid that's coming to my mind is the phospholipid. 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 Phospholipid is a group of fatty acids, two fatty acids together that is attached to a phosphorus. Phosphorus is an element of the periodic table. Phosphorus and two fatty acids. Now, this phospholipid that is composed by fatty acids are one of the main components of the cell membrane. Open eyes, open ears. When I say open eyes, open ears, it's for a reason. Okay? So that is the fatty acid. So the cell membrane is composed by fatty acids. And those fatty acids in the cell membrane are called the phospholipids. Okay. Now, the saturated fat is animal fat, and the unsaturated fat will be, for example, olive oil, for example, avocado, omega 3. Omega 3. The unsaturated is coming from actually vegetable source. Tell me, somebody can answer me where it's coming from or where you can get omega 3.
Fish?
Fish? But fish is an animal or a plant?
Oh, that's an animal.
So how come? So omega 3 is unsaturated fat that is vegetable source. And the answer is again very simple. Yes, you're totally right. It's on the fish. But you say, but the fish is not vegetable. Yes, it's not vegetable. But why the fish have omega 3? Because the fish eat a lot of algae. That's why. A lot of algae, huge amount of algae. And algae, what is that? Vegetables. And that's why we have omega 3. You okay with that?
Okay.
Okay. Then we have the triglycerides. The triglycerides are going to be triglycerides are composed by three fatty acids, three glycerides, three fatty acids plus one molecule of glycerol. So these three fatty acids are going to be broken down, divided in pieces, and turned into three fatty acids. So they go to the other group. So they return into what is fatty acids, triglycerides. And the last one, cholesterol. What is triglyceride? Lipid. What is triglyceride? Fat. Very good. What is cholesterol? Fat. What is cholesterol? Lipid. Very good. So that is the same. Cholesterol is a precursor of what we call steroid hormones. Steroid hormones. Steroid hormones. What are the steroid hormones? So you heard, for example, in the news, oh, somebody is taking steroids. Yes or no? Right? Or no?
Yeah.
Okay. And everybody's saying, oh, yes, it's testosterone. It's a male hormones. Yeah, it's okay. But especially people who are doing a high performance physical activity. Okay. And the steroids is called the steroids. Who are those? Write down this. Number one is going to be testosterone. Steroids are estrogens. Steroids are progesterone. So those are sex hormones. So all the sex hormones are steroids. Another steroid will be the cortisol. 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 And the other one is and the last one, aldosterone. 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 So all these hormones are coming from the adrenal gland. All these hormones coming from the adrenal gland. And all these hormones, in order to be produced or synthesized, you need cholesterol. Okay? So your body needs cholesterol to produce steroids like estrogen, progesterone, testosterone, cortisol, and aldosterone. Now, why is called a steroid? Listen to the music. Are you ready? Listen to the music. Cholesterol, cholesterol, steroid. Can you see the similarity? Yes or no? Hello?
Not really.
All right, I'm going to write it down. Not really. I'm not a good singer, I guess. Look at this. I'm going to write down cholesterol. 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 And I'm going to put here Steroid. Steroid. Now, look at that. Can you see that now?
Okay, yeah.
Right? Cholesterol, steroid. So steroids are coming from cholesterol. That's why they call steroid, because they actually coming from the cholesterol. You okay with that?
Yes.
Excellent. All right, so just one more time. So you already know that the cholesterol is going to serve as a precursor for the synthesis of the steroid hormones. You know what are the steroid hormones already. Triglycerides are the main component are 3 fatty acids plus glycerol. Open eyes, open ears. Glycerol. So the backbone of the molecule is the glycerol that is attached to 3 fatty acids. Okay. Okay. Just remember, when we're talking about saturated fat, when we are talking about saturated fat, is animal fat, solid, correct? Solid, yes or no? All right, so trans fat. What are the trans fats? Somebody can tell me what is trans fat?
It's man-made, right?
Yes, so
Uh, it's to help burn slower. To
very good, yes. Why
uh,
trans exist?
uh, they changed the molecule to make it burn slower, and it ends up making the oil a lot worser.
Yes, last longer, right?
Yeah.
So in the past, with animal with saturated fat oil, the lard, for example, is more delicious. Some when you're getting into school, I will tell you why humans like fat. Not, not right now because we have a few minutes. Yeah, and the saturated fat, they was basically you can fry fries 24 hours without burning the oil. The vegetable oil is burning very fast, and the taste is ugly, very, very, very bad. In addition to that, the government in the 50s, I didn't born yes, still, okay, in the 50s, they uh, they know that saturated fat can produce a lot of cardiovascular problems, myocardial infarctions, heart attacks, and strokes as well. So that's why they changed the saturate into actually the unsaturated. That it was the ideal. But the unsaturated vegetable oil was very expensive. All McDonald's, all these guys were going to be in the bankruptcy. So they need to do something like urgent right away. And what they did is to take the vegetable oil and transform into uh, changing one hydrogen into something similar to the saturated fat. So now the oil of the unsaturated fat transform into trans fats are going to last longer, and they have make it cheaper everything for the business, right? And that is what is the trans fat. The trans fat, because it's a man-made, the body doesn't know how to handle the trans fat. So when you eat trans fat, when you want to lose that fat, trans fat, how long do you think you can lose that fat?
I remember in your video you said 9 months.
9 months.
Excellent, excellent. 9 months is like having a baby, right? So 9 months of suffering, of doing exercises, and that fold in our abdomen is not going away because the trans fat is just new, man-made, and the nature is not in the nature; it's man-made. So our body doesn't know how to handle that and destroy for the next 5 months, 9 months. Okay, perfect. So let's keep going with that. So margarine is a good example of trans fats. So trans fat is actually margarine. Okay? For example, one example. All right, so you need to remember what is HDL. The HDL is the HDL, the happy cholesterol, the good cholesterol, happy. So why is happy? Because we are happy. Why? Because whatever you eat, cholesterol, this cholesterol go to the liver, and the liver eliminates through the bile. That is actually going out. So you eat cholesterol, but the cholesterol is going out of your body. But the LDL is the actually the bad cholesterol. But it's not really bad cholesterol because we will talk about that another time. This LDL is going to make something different than the HDL. The LDL, whatever you eat, they are going to go to the cells. They are going to go to the cells of the body. So, for example, the HDL and the LDL, what are transporting? The transportation of cholesterol. Cholesterol, that is what is doing the HDL and LDL. Who is the taxi driver? The protein. That is called lipoprotein. Lipo, fat, cholesterol. Protein is the albumin. So the taxi driver, albumin, transport the cholesterol. That is the taxi driver company HDL and the taxi driver company LDL. So the HDL go to the liver, but the LDL go to the cells. And this LDL is good. I'm not contradicting. Just wait. So LDL is good because your cells who produce steroids like aldosterone, cortisol, and sex hormones, they need cholesterol, and these are being delivered by the LDL. So it's good. It's good. But what happened later? What happened is that you already produce all the sex hormones that you want, all the aldosterone and cortisol. And when the LDL come in with more cholesterol, you say, "Do you want cholesterol?" "No, I don't need. I don't need it." Why? Because I already did what I need to do: sex hormones, cholesterol, cortisol, and aldosterone. So what I do with this? What it's doing is dump it. We're going to dump it into the arteries. And that is when you have, it's called the bad cholesterol. So when you eat cholesterol in excess, or fat in excess, that is what is happening. The LDL is good. It's accomplished its mission. But the problem is when you have too much fat eating. So LDL cannot deliver into the cell because they don't need it. They don't need it. Okay? All right, so we okay with that? Okay.
Yes.
So now DNA and RNA structure. The RNA is single strand, a single strand. Meantime, the DNA is double strand. Why double strand? Because they protect to each other. The difference between the RNA and and the DNA is the RNA contain the uracil. Uracil, the uracil. What is the base that is not replacing the uracil? Remind me because I forgot.
It starts with a T.
Timing.
Thymine.
Very
Yeah.
good. The timing. Excellent. The timing is going to be in DNA and the uracil. Instead of the timing, we have the uracil in the RNA. RNA. All right, so now you need to remember that we have the production of proteins from the nucleus with the RNA messenger. Inside the nucleus, we have what we call the transcription. Transcription. What is the transcription? Transcription is you copy the recipe. What is the recipe? It's in the genes. So you have, for example, a DNA is a book of 24,000 pages. Can you imagine a book of 24,000 pages? Okay? So these pages are going to contain recipes. Recipe. Each page represents a gene. Each page represents a gene. So what is a gene? A gene is a recipe for proteins, not for carbohydrates, not for fat, not for nothing else. It's a recipe of how to cook the protein, a protein. All right, so this transcription happens inside the cell, inside the nucleus, and the translation occurs in the cytoplasm. Transcription, who is first? Transcription starts with C, and translation is after C. So that is first transcription and then the translation. All right, so in addition to that, number three, we need to go into what we have, the cellular and molecular biology. What are the main components of the cytoplasmatic membrane or the cell membrane? Cell membrane is the same to say cytoplasmatic membrane, and that is two main components: phospholipids, that you already know what it is, and the proteins and protein. That is the main. No, they're not the only one, but the main are going to be the phospholipids and proteins. We have in addition cholesterol, but cholesterol is not considered the main component of the cytoplasm. Mitochondria is called the power plant. That is where inside there we produce the ATPs. Just remember that some of the components like these proteins, the proteins are composed by what? By amino acid. That is the unit of the protein. It's like you have a wall with bricks. The whole wall is called protein, and each brick, single brick, is going to be an amino acid. All right, so another thing, talking about tissue, just remember, I want you to remember the glia of the, jumping a little bit to another topic, glia and neuroglia. Glia is a nerve cell that support other cells. So it's a supporting cell. So the glia or neuroglia are going to protect and support the nerves. That is the glia neuroglia. Okay, so we have other concepts I want you to remember: the hydrophilic versus hydrophobic. Hydrophilic is philic, means love something. Hydro, love the water. For example, water. We have hydrophobic. Hydrophobic means phobia. You scared? You have phobias? Okay, so you're afraid of that. So afraid of water, and that is the oil. Hydrophilic and hydrophobic. All right, so we was talking about memory transportation as well, and the main examples I want you to remember, just to bring it down to a few words. Simple diffusion and the facilitate diffusion are passive transportation. That means that they do not need energy. They don't need to use energy. What is the best example of simple diffusion? Is the gas exchange, carbon dioxide and oxygen. What is the best example of facilitate diffusion? Is the absorption of nutrients by the cells of the intestine. Okay? And osmosis, you already know about osmosis, so please review osmosis as well. What is hypertonic, hypotonic, isotonic? And all right, so now let's go to the, you remember the simple diffusion, facility diffusion, the particles go down the concentration gradient. Down the concentration gradient. What does it mean? Gradient means the comparison and the difference between two spaces. So, for example, outside is high concentrated molecules, and inside low concentration molecules. That difference is called gradient of concentrations. So when you see concentration gradient, means that one side is high concentrated and the other side is low concentrated of some substance. And that is going to lead into the osmosis. It's called down the concentration gradient, because the particles are going to pass from the high concentration to the lower concentration. And what for? To have equal concentrations at the end. So if you have more in one side and less in one side, you want to have equal, same. So that's why they pass molecules. For example, you have 1,000 on the one side, and the other side you have 500, right? Or 400, just to make the math, 400. So at the end, they go from high concentration to low concentration, and 1,000 plus 400 is 1,400, 700. So you will have 700 in one side and 700 in the other side. Okay? You okay with that? Okay. Homeostasis, please review the homeostasis. Free radicals, what are free radicals? Are going to be having an extra electron. It's the hot potato in your hands. Okay, and remember the ATP. The ATP, we have three phosphorus, 1, 2, 3, and you write it down from left to right, 1, 2, 3. Why I'm doing that? Because, question, open eyes, open ears. The highest concentration of energy is between the second and the third phosphorus. And that's where you are going to basically break down in order to do all your activities. Just remember, the food is needed for energy to produce ATPs. But we don't use the energy directly from the food. No, because that energy coming from the food is to produce ATPs. And then we use the ATPs as a form of energy. All right, ladies. So that is the time I can go over with you. So just take your exam. We have heart anatomy, the valve function, the valves of the function. So the tricuspid, the mitral, abdominal anatomy. Please remember all the abdominal regions, 9 regions, and what we have in each region: the liver, the stomach. Sorry. Hello. Just a moment. Hello. Yeah, I've been here from 4:10. So I'm going. Okay, so we let's finish this because I have just a few moments. All right, so regions. Don't forget about the regions. 9 regions. Um, all right, so you know what is mediastinum? Mediastinum is located in the thorax. Do not belong to the abdomen. Then we have the respiratory system. You need to know the division. What is upper and lower respiratory tract? You must not know that. From the nasopharynx to the larynx, that is what upper. And so trachea to the lungs is the lower. You need to remember that epiglottis. Epiglottis is a cartilage that is going to close when you swallow. What is going to close? The respiratory tract. Because if you don't close the respiratory tract when you swallow, the food goes to the lungs. When you close the door, the only place they can go is to the esophagus. Okay, so review that. So we have the lungs. The lungs, we have 3 lobes on the right side, on the right lung, and we have 2 lobes in the left lung. Okay, so the most important respiratory muscles will be the inspiration. For inspiration is the diaphragm, and for expiration the intercostal muscles. All right. So, and the last, please just remember all the health dimensions. How many health dimensions we have? We have six dimensions of health, right? Six dimensions of health. You need to know at least one example of each. Emotional health, for example, social health, for example, right? And at the end, you need to remember what is a prevention. Prevention. Primary prevention, secondary prevention, tertiary prevention. All right, ladies, thank you so much. My class is populating right now. I'm going to start doing pharmacology. Muchas gracias for coming. Any comment or any suggestion, please?
I have a question about the assignment 7. Is it due on Wednesday or Monday?
Is the next so the what day is that?
That's what I'm trying to figure out because we have a exam today.
Go
So
to the calendar. You need to see the calendar.
okay,
The calendar. If not, text me. I will guide you on that. But
okay,
in the
thank you.
calendar, please, is followed by day is the date there, the date and the date and the number of the day.
Okay,
And always the lecture that you have today is going to be done the next lecture. So, for example, today is Friday. You have the exam one, right? But all today should be all the previous to the exam one. All the homework should be already done. So you have time until 11:59 tonight. Okay.
okay,
Thank you. Have
thank
a
you.
thank you,
Okay, thank
everybody.
you.
Thank you too, Sabrina.
Thank you. Bye.
Oh, by the way, wait, don't go, don't go, don't go.
Okay.
I'm going to post and tell everybody. I'm going to post the recording in the on Moodle.
Okay, thank
Okay,
you.
but the
Yeah.
recording is going to take the machine is taking like system like 1 hour, 2 hours. So I cannot post it after that. So okay, so but I will try to do it in the next couple hours.
Okay, and then we have to finish the test by today at 11:59. It has to be done.
Yes, yes.
Okay.
Okay,
Okay.
thank you.
Thank you. Okay,
Good
bye.
night.
Good night.